I'm going to look at energy partitioning and then sequential blasting and the use thereof, and going back to the basics. It's been mentioned over and over today. The basics it's what it's about. A lot of us have forgotten those basics, and you were spot on with all of that. With anything, I always say stick to what you know. Get to the base case first. So often we get asked to come and help and just fix something, and everything like just the simple base case to understand where you are right now before you even make that first change is of critical importance. Without it, doesn't matter what project you take on. May it be a cost saving, may it be efficiency, may it be a value add, as it means nothing if you haven't done your base case. Not knowing what you want to achieve, like in your case now, better blasting conditions, safer blasting conditions. Please don't forget that base case. So often it's forgotten in operations, and people are so pressurized to produce and go forward. Just some reasons for faults of ground. Typically, obviously, your geology, your rock bursts, mining methods. People forget that different mining methods, board and pillar is very different from stoping, is very different from development. Development that's a follow behind compared to capital development reacts very differently. And cognizance of that must be taken. Knowledge of workers, we've dealt with that over and over today. Understanding what impacts blasting and drilling has on various things is of critical importance, and you mentioned it over and over. That base, do our people still have the knowledge? Must be, we must look at that and ensure. I want to also bring to the light that everybody is involved in reducing falls of ground. It's not a production thing only. It so often becomes that man on the face, and it's not. So often I find going underground, you have the planning people that have put the tunnel in the wrong place. Simple as that. Geology-wise, they haven't highlighted the fact that we are actually in a fracture zone here, and by just moving the tunnel or just changing the elevation of the tunnel so often can make the world a difference when it comes to fall of ground. The old plan, do, measure, review is also largely forgotten, and it goes back to my base case that I say. Make sure you understand where you are now before you move forward. Then I obviously want to just hone in on the priming and charging being part of explosives, and I'm going to challenge you now to hopefully something new. Explosives, Tony Rourke, everybody here, it's just a different way of saying it. Frick also mentioned it. I see blasting, drilling as energy, energy, energy. Where you place that hole, the burdens and spacings you use, what drill bit size you're using, all have an impact on your blasting results. Are you using the correct timing for a tunnel? It makes a huge difference. Sorry. I do tend to push everything to the extreme, being 6'8". Sorry. Special conditions. So often mines have a standard. A 3x3 round is 7x7 rows, and no matter what the ground conditions are, it's 7x7 rows. The people have forgotten how to read a face, how to assess after the blast what has happened. They see these massive sockets on the face, or these perfectly round sockets, and they don't understand it. They just don't even look at it. So often I've asked the question, why have you got big rocks on the pile, not underneath? It means nothing. They've lost the art of actually understanding what's happened because of the blast. And that's the training that you mentioned. That going back, that training needs to change and get into the nitty-gritty again of what we do on a day-to-day basis. Why I brought in everybody, planning, procurement, everybody. There's so many tenders, so many pricing going out, and I find so often that mining people have let critical key elements of procurement to the procurement people. Procurement people don't understand everything in blasting and drilling. They might force you as users to use ANFO because it's the cheapest. But is it the correct explosives for the correct application? And that's where I'm going. I'm not saying you must use the Rolls-Royce where you need a tractor, and vice versa. I'm saying use the correct accessory, the correct explosive for the correct application. And so often, procurement makes because it's the cheapest, you will use this explosive for everything. And I find that so sad. The list of explosives and accessories to mines should be endless. It should be everything so that you can use the correct stuff at the correct place. Looking at this, it hones into some of the slides in a different way. The physical effort, the cleaning of the panel, then obviously the preparation, all of that, the drilling, the marking, that has an effect on the result. But if procurement has given you particular only, say for argument's shock tube and only emulsion and only it will in certain incidents result in different outcomes. May result in huge wasted energy. May result in fractured ground that you shouldn't have because you've used the incorrect product for the application. And so I ask, you know, that when people look at it from all angles, look at it that, yes, I've got the correct job, product, correct timing, correct application, and you will get the best results that you can wish for. We're all in the business to get the best out of what we do. You want to get the most advanced. It's been mentioned here, extra 5 centimeters will result in massive money. But so often we are still stuck in the past. Frick, you mentioned it, 70 degrees. To me, that is the old standard of cap fuse, igniter cord, downer gels and gel ignites. We've moved on from that. Explosives today are so different. Explosives is not your limiting factor to blasting. It's the people, it's the application, it's those basics. Please, the old standard where whatever the stoping width was, that is the advance you can achieve, is not so. Not anymore. The old standard of whatever the tunnel width is, that is the advance I can get, is not so. That is cap fuse, it's different today. I'm going to show you something now. 36 centimeters of void, for those is an empty hole or relief, is 1 centimeter of relief, sorry, is 36 centimeters of advance. I'm going to show you something here. A 1 by 1,2 by 1,2 little raise, advanced 5 by 5,5 meters. Safely. You showed barrels, I dare anybody to come up with this. There's a tunnel there, 4.2 by 4.2, 8.5 meters advanced. 5 by 5 tunnels advanced 26 meters. Per blast. It's not blasted, it's per blast. But look at the condition of that tunnel. The logic is using your logic, it's energy partitioning, using the correct product for what you want. If that means electronics, the comment was made, electronics is expensive. If you blast like this, it's worth nothing. It's nothing. It's not an effort. It doesn't mean anything to you because you get so much back. I mean, those tunnels are perfect. I'm not saying that we must go with a 26-meter advance in our conditions. Our levels are seriously deep compared to the South Americas, the Canadas, and that. I agree to that. But there's no reason why we can't do that 4.5 meter. The 3 meter that we want. There is no reason why we can't take out a round without a socket. It's using the correct product with the correct application. There's theory behind it. I don't think we have time being reduced because we're running late. There's theory behind that. I'm going to show you something now which goes against the grain, because everybody always wants to charge the holes up completely. The only people that smile is Sasol, BME, and AL because of that. We love it. Mine's used 36% more explosives than they need to on average. Using the correct product, correct application, you can get this by using theory. It's been proven. There's typical standards. The distance from a relief hole to your first production, depending on what it is. I just use a 38mm drill bit, which, because it's quite common, gives you about 171. But we use what an equilateral triangle rule, and I'll show you in the next slide. Relief. Overseas, if you go to Sweden, Norway, South America, Canada, they go to the good, the bad, and the ugly. The good is what they call an S cut or an F cut. To me, it looks like 2 5-hole cuts, burn cuts put next to each other. Why? Because they want more relief holes. It's all about the relief. If you've made the void, whether that's a stoping, a board, and pillar, the rest of the blast will go. Where do we always find our hassles? In the cutter and the easers. Short holes, skew holes, not drilled, no relief holes, all holes charged up, that type of thing. It's the key to success. That's where it is. Once that doesn't go off, I promise you, you're putting energy into the surrounding rock. We've discussed that today. And you will get faulty conditions. You will have falls of ground. Timing. It's not just about standard timing anymore. It's not that 3,800 or 4,200 anymore. It's about using the correct timing for the correct application. There's just a very simplistic rule that it's over time has developed into that. For us here, in our conditions, hard rock, 40 milliseconds per meter. 3 meters, 1.2 seconds. That's what you're looking at. Whether it's shock tube or electronics. Yes, there's been comments made that shock tube's not as accurate as electronics. In short holes, I promise you, you'll get the good effect that you require. If you go to the extremes, like I showed you, electronics, it's using what you need for the application. There, just to show you the good, the bad, the ugly with the cut. I didn't finish that. Is the S or the F cut they call the good, the bad they call the wedge, and the ugly they call the burn cut. Overseas you don't see it anymore. It doesn't get used anymore. It's all about that relief, that stab holes. There's multiple. So often people don't want to use a bigger drill bit. I understand that we're on handheld drilling and all of that. What is our standard burn cut? A 9-hole's got 4 relief holes. But if you work it out properly, you need 6. It's critical. Just 2 extra holes can make all the difference to your whole tunnel, or your board and pillar, or your stope, or whatever it is. It's not rocket science. It's keeping it simple. It's keeping it to what we know. The equilateral triangle, they don't mark off the old grid anymore. I use the equilateral principle. I've seen tunnels, 38mm drill bit, 1.35 meters drilled apart. It breaks clean. So that's where I'm going. The old rules of it had to be 50 by 50 or 30 by 30. It's not true anymore. But the relief is where they focus everything. That cut and eases is 90% of their focus. That's what they think about. There you can see there the equilateral triangle for a simple cut. It gets bigger and bigger, obviously because your base is bigger and you divide it by 1.155, it gets bigger and bigger. We've already got graphs like the one there on the right, where you can actually, you don't have to learn anymore. You know, those learnings have been developed. Here's a typical tunnel. You will see overseas as well, they use ANFO. You will never see ANFO in a cut and easer, even though it's an ANFO tunnel. You will never see ANFO in smooth walling. It's not used for that. They don't believe in it. If you look in the cut as well, you can see there the powder factor of 0.4, 0.6. You will go, my God, is it going to break? You just want to break it. You don't want to kick it 5 miles down the tunnel. You just want it to lift out, break out, and then you start kicking it out with your production holes. What they also do is a cut will never be blasted 2 holes at the same time. It's always 1, 1, 1, and always the bottom last. Why? To kick out, to lift out that broken rock, to make sure that it leaves you with that void. Your ease is exactly the same, 1 hole at a time. From there on, now your void is that good 1.5, 2 meters or whatever it is, and you start doing multiple holes. But look how high that powder factor is for production holes. It kicks it out really hard. But you've got that void. So the energy is going to the center, it's going to the cut, it's not going to the rest of the tunnel. Take out the whole heart of the tunnel first, then the side walls, then the hanging wall. Why the foot wall last? So that you can kick it free. You do the corners last, and the next day you can do your safety inspection quite comfortably. They're also very focused on putting the cut in the right place. For those who use drill rigs, your drill rig driver always sits on the left-hand side. Your cut is on the left-hand side. Why? Because all the rock lies on the left-hand side. He can see what he's loading. If you try and do it yourself, try and load on the opposite side of the tunnel. He's working in darkness, that person. He has no idea what's going on there. And that's why tunnels don't come clean. That's why board and pillars don't come clean, because he can't see what he's loading. Similar for just a normal stope. I put something in there. We've done this at Anglo and at Impala, using the relief holes there at the bottom of the stope toe. Just 3 little empty holes. But it avoids that breaking of that foot so that your pack can be put into solid ground. The old breaking it that way. Taking the 2 out and kicking it towards the footwall. Tony mentioned this slightly. Yeah, once again, it's using the correct product for the correct application. ANFO is cheap, but it comes with its inherent problems. Water gels is probably your most user-friendly product, give you the best results when it comes to grams per ton in gold. We'll do the same for platinum. But emulsion is becoming more and more the way, but pumpable water gels should be the way. Just the 2 detonators. I mentioned that electronics is expensive. I don't believe it if used in correct application. And that's it. It's about us moving from the old product delivery, becoming a strategic partner with you guys. And I'm not talking on behalf of SAP, I'm talking on behalf of an AL or a DME. Use the guys and get